Hi friends, in our previous video we have seen what is Docker Swarm. So in our previous video we got the concept of theoretical parts that what Docker Swarm is. Now this will also be a theoretical session. So in this session I will discuss actually how Docker Swarm works, what workflow Docker Swarm follows. So already I discussed in my previous session that in the Docker Swarm we will have one or more than one manager node and rest will be worker node. So what worker node does that whatever containers we will run from the Docker manager command, all that container will be running in that worker node. So we can deploy one manager as well or more than one manager as well. So how this manager works and how this communicates, this I will discuss in this session. So see, first of all, Docker Swarm is a container orchestration tool which lets us to create a container of Docker nodes. Already we have seen that what is cluster in our previous session, what is cluster and how it communicates. So this is just Docker Swarm we have discussed. So see, in cluster we can make one node as manager and remaining node will be as worker. So we can make one node as manager, but it is not recommended. We should make more than one node as a manager. Why this is reason? Suppose you are running one node only as a manager and that manager host goes down, then your entire Swarm cluster will go down. Your entire Swarm cluster will not work. No server will be able to communicate with each other. So whatever the Swarm features we were using, we moved out of that. So it is always recommended to use more than one Docker Swarm as more than one manager in the Docker Swarm. So we can make more than one manager as well. It is only up to our choice only. But manager node should manage the container task. Yeah. See what I said earlier that suppose I will be running 20 Tomcat server from this Docker's master or Docker manager server, then this 20 Tomcat server will be distributed among this 4 worker node as well as this master node. So it will be distributed among these 5 host machines. So we should make the manager server or master server to do only the management task. What the management task is? Suppose I want to create some containers, suppose I want to add some host to the cluster, suppose I want to remove some host from the cluster, I want to remove some container. So this all related task will be done by the manager node. So I have to make this manager node to make only management related task decision. So it should not run the container also, because if it will run the container also, your performance will be down, your performance will be reduced. So it is not recommended. So we should make the manager node to work only for the management related task. And how we can do, we will see it in a practical session. So this is already we discussed. By default, container runs and means already I said that whenever we will run any container, it will be running in by default in manager node as well. So we have to make the manager node to run only management related task only, not with the containers and all. So this already we discussed. So yeah, and how I will identify that this manager is running only to means management related task or all the task. So what we have to run, we have to make the availability as drain. So what actually it is? See, now let me come into a server. So if I will run docker info brief swarm. So see, right now my swarm is inactive, means swarm is not working. So what is the first step? I will run docker swarm init. So what it will do, it has made this server as my master server. So in this server now Docker Swarm is running. Okay. So if I will give Docker Swarm, you see what I had said here that this availability is drain. Okay. So now here I will see Docker node inspect master1. Okay, sorry, we have given master, but the name of the host machine is master1. So we have put it master1. See what we are getting. When I run this docker node inspect master1, so I am getting all the information related to this master1 server. Okay, so if you will come downside, you will find availability over anywhere. So let me look for the availability. See, here we are able to get it. So this inside this spec, if you will get the availability, by default it will be always as active, and if it is active means all the tasks which I will run from the docker manager, it will run on the docker manager as well as the worker as well. So I have to make it as drain. So let me show you how can we make it as drain. Docker node update -a b a I a b I a t y b r a i n m a s t e r 1. See what happened. I run this command to make this as drain. Okay, if I will run the drain, then after that whatever task I will run, no task will be running in master1 server. It will only run in the worker server. Okay, so if I will run again that inspect command, so I will see that now you will see that this availability is drain. Previously, if you will notice, this availability was active, and now this availability became drain. So this is what modification we have to do. Okay, so this is what I explained over here. These all things you will get clear when we will move to the practical session, but before that it is necessary to at least get some idea on the theoretical session as well. So I am sharing all this story. So this availability we have shown. So see, now we will come to the workflow of the Docker Swarm. How the workflow happens. Okay, so with Docker Swarm we can distribute our different services in different hosts to achieve the high availability and load balancing. See, already we have seen with the Docker Swarm, when I will initiate the Docker Swarm, I will be able to run my entire multiple application in more than one server, and all these servers will be able to communicate with each other. So what it is saying that with the Docker Swarm we can distribute our different services in different hosts to achieve the high availability. And what will be the advantage of this? Suppose if previously I was running all the containers on one host only, and if this host goes down, so all the containers will go down. So if I will host this containers on multiple host machine, so suppose my one host machine goes down, so these containers will automatically bring up in other host machine, so my availability will be high. Okay, so this is first, and this the second one is the load balancing. Previously what happens, suppose if I would have running all the containers on one server, so there would be more load on one container. Suppose if at a certain time a high traffic comes in, so that time my server will go down due to high load. So load balancing is also enabled in this Docker Swarm. So how it works? See, Docker Swarm automatically comes with the Docker engine. Already I have shown you there that we don't have to install Docker Swarm separately. If I will run this docker info command, so you will be able to see that Docker Swarm is active now. Now Docker Swarm is running in my server. So we don't have to install Docker Swarm separately as we did with the Docker Compose, because the Docker Swarm is not the third party tool. Docker Swarm comes with the Docker engine only. So now the time comes to make this server as manager or master server for Swarm and remaining a slave. So this all I will show you details in the practical session. So what I have written over here, see what we have to do. Previously my Docker Swarm was not there. Suppose Docker Swarm leave -force. So what I did, I just left out of Docker Swarm. So again if I will see, my Swarm goes inactive. Okay, so what is the first step? That first you have to initiate Docker Swarm in any of the server. See, I have created 4 server with me. I have assigned the host name as well. For this server I have given master 1, and for the remaining server node 1, node 2, node 3. So I am having 4 servers along with me. Okay. So what I want to say that if I will see now Docker Swarm is inactive. So on top of whichever server I will run this command Docker Swarm init. So on that server, that server will become my master server, because this initiates the Docker Swarm. By running this command, Docker Swarm will activate. So on top of which server I will run this Docker Swarm init, that server will become my master server. Got it? Now, okay, suppose let me run this command. So what will happen? This server will become my master server. See what output I got. I got that Swarm initialized, means this server became my master server. Current node, this one, is now a manager. Already I got the message as well that this node became your manager. So now what I said earlier, that in this Swarm, one node will be manager, or more than one node can also be manager, but by default if you will consider, one node is manager and more than one node will be worker. So what I can do, say, this is the command I got to make other node as worker. So see, if I will run this docker info brief Swarm. So I am written Swarm is inactive in this server. Okay. So if I will run this same command in this server as well, then this server will also become my Swarm master. So I should not do this. See what is the process? I should first make only one server as master, and with this master server I should join to other server. I should make other server to join in the Swarm cluster. So what will happen? All these servers will be able to communicate with each other. So when I run this docker swarm init command, so what is happening? I got one token key. Okay. So if I will run this docker node ls, so right now I am getting that in this swarm cluster only one server is there, which is a part of docker swarm. So this already we are getting. So if I want to add other server also into this cluster, so I have to copy paste this command to any of the host machine whom I want to add. So this is what message I got after running this command. This node joined a swarm as a worker. So if I will run this command again, docker node ls, so I will get there that this node 1, this is the node 1 is the name of this server, node 1. So this node 1 also joined this cluster. Okay. Now remaining thing I will explain details in other separate video, because this video I am making for the theoretical parts. Okay. So what I mean to say that this my manager node, in one of the server I will initiate my docker swarm, and that server will become my manager node, and in the other server I have to run this token. So that server will join my swarm cluster. So that is what it is saying. We can have a single manager node as well, but it is not recommended, because if it fails there will be no manager nodes to manage the cluster. So for fault tolerance we can have multiple manager node in a single cluster. So it is always recommended to create more than one manager, and for the best practice 3 manager node always should be there. Docker says that 3 manager nodes is the best for the best practice. So we should have at least 3 manager node to get the best output. Okay. So that suppose if one manager node goes down, automatically second manager node will come up. So how all this happens we will see in details in the practical session. So already we have seen docker node ls. Docker node ls command gives us the details of how many nodes have joined to our cluster. Okay. This is the docker node ls command does. So this is important, because if the leader was to make it is, yeah. Now see, it comes to the concept that what is means, as of now I have seen that one master node is there, but more than one master node can also be there. Let me show it practically. Docker swarm join token manager. So this command, this docker swarm join token manager command gives us the token. This is also token. But with this token, if I will run to the any server, that server will become my worker server. Okay. So I want to add other server as a manager. So I got this command. So when I will run this command in any of the, suppose I am running this command in my second node 2. So when I run this command, what message I am getting? This node joined Swarm as a manager. So if I will run docker node ls, so what I am getting? See, first one is the leader. Leader means this is my master node, and the second reachable. Wherever I will get the reachable means this node has joined to the cluster as a master. So whenever suppose this server goes down, automatically it will become the master. Automatically it will become the master. So how it becomes, we will see in practical session. So what I mean to say that, now see, these two leader came up, these two manager is there with us. In a cluster we are having node 1 as a worker and master 1 and node 2 as a manager node. So suppose what happens, the question comes here, there are two manager nodes, then who will take the decision that what commands need to run, what changes need to be implemented, who will take the decision, who will take the ownership. So obviously those who will be the leader will be always taking the decision. But again the second point is, never the master or leader who is the manager node takes the decision by their own self. Whenever the master has to take any decision, they has to consult with the backup of the manager node as well. Suppose here I am having two manager node, one is the leader and the second one is staying there as a backup. So this node cannot make any decision by their own. Whenever this node want to make any changes, it has to contact with this node 2 and it needs to take a permission to make any changes. So how it happens? So see what happens. What Docker Swarm rule is, suppose if you are having 5 manager node with you, so to make any changes, you should have a vote of at least majority of the manager. Suppose 5 manager is present in your Docker Swarm and you want to make any changes into the Docker Swarm cluster. Suppose the leader of the Docker Swarm want to make any changes in the cluster. So that Docker Swarm 5 manager which is present, the leader can't take any decision by their own self. To take any decision, out of the 5 manager node, it would have got the vote of at least 3 managers. Means what I mean to say that, if suppose 5 manager node is there and if you want to make any changes, then at least 3, means n plus 1, n by 2 plus 1 votes should be there with you. Then only you will be able to make any modifications. Means what I mean to say that, let me show it practically. Say suppose I am having this one swarm manager is over here. Suppose in my cluster I am having more than one swarm manager. This is second swarm manager, this is third, this is fourth, and this is fifth. Suppose I am having 5 swarm manager with me. So let me write the name as well. M1, M2, this I am giving name as M3, this I am giving name as M4, manager 4, and this I am giving M5. So what I mean to say that, suppose this manager 1 is my leader node. This is my leader. Okay. L-E-A-D-E-R. Leader means who is making any changes to this cluster. So this manager M1 is my leader node, and this M2, M3, M4 and M5 is present in the reachable mode. Which reachable mode we have seen over here. In the reachable mode they are present, means they are standing as a backup. Suppose if my M1 goes down, then this M2, M3, M4, M5 will take care of this one. So see how the action goes. Suppose M1 has to take any decision, M1 has to make any changes, then by their own M1 can't make any changes. M1 has to send the notification. Suppose M1 want to remove a host or add a host, then M1 first will send the notification to all the remaining 4 manager node, and from the 4 manager node it should at least got the agree of from at least 2 manager node. Means out of 5, if at least 3 manager node will agree for the changes, or majority of the manager, or either all manager, then only modification can be done. Means to do any modification, M1 need to at least get a vote in their favor from at least 3 manager node. Then only any changes could happen. Then the question comes, why this such type of scenario is going on? Why M1, when M1 is leader, then why M1 can't do any modification by their own? See, let me show you from with a example. So see what I mean to say, that this is M1 my manager, okay? This is M1 my manager, and this M2, M3, M4 and M5 is present as the backup manager. Now suppose M1 would be taking all the decision by their own. Suppose M1 don't send any notification to all the remaining 4 manager. Then we can take an example that M1 was about to add one host machine to this cluster. Already 4 host is there. M1 was about to add one more host to this cluster. So this cluster, this host machine was coming inside the cluster, but before the new host machine came up, this main manager node went down. This M1 went down. This M1 is no longer present in our cluster. So what will happen? The newly server host 5 which came inside the container, none of the manager would be aware of that container. That, oh, this container came up from manager 1 and this should also be part of the cluster. So what will happen? From next time onwards, when the manager 1 will go down, then as per our rule, any of the manager will become the leader out of this 4. Then suppose whoever will become the leader, they will be unaware of that this 5th host machine came up only from the manager 1. So they will not be able to take care of this 5th host machine. So what will happen? Whatever the container is running inside that 5th host machine or whatever, it will become inconsistent. In future, if the manager is going to make any modification, they will consider only this 4 host machine. They will not consider the 5th host machine. So a big challenge will come into the figure. So that's why to make any modification, always manager should communicate or send the notification to remaining manager, and it should get the approval from at least majority of the manager. Then only they can make any changes. So that if in a case suppose the leader manager goes down, the other backup manager will be aware of the changes. These changes took place only from the main leader manager, so that no issue will come. So this is what I want to say, and this algorithm we say is raft algorithm. This process which I have explained you now, this is the algorithm, and in the Docker we say is a raft algorithm. Okay. So in the raft algorithm, one more process is there. See, I had shown you that, now I have explained you that to make any modification, our leader manager M1 need approval from the majority of the manager. Now second question comes, let's suppose if my leader manager 1 goes down, this my manager 1 goes down. So who will become out of these 4, who will become my leader manager? So because every manager will want to become the leader, then who will become the leader manager? So there we follows the raft algorithm. So see what raft algorithm does. Raft algorithm will send a random timer. This will send a random timer to all these 4 remaining manager, and whichever manager will respond at first, they will be offered to get the approval from the remaining manager to become the leader. Suppose let me explain you with an example. Now let me choose the different color. So what I mean to say, suppose my manager 1 went down, okay. So now manager 2, manager 3, manager 4 and manager 5 is up. So out of these 4 managers, everyone want to become a leader. So who will become the leader? So what the Raft algorithm says, it will say a random timer to all these remaining 4 managers. So those manager will be responding first. They will be offered to get the approval or vote from remaining manager. Suppose manager 2 replied the first, manager 2 responded first, then manager 2 will be sending their vote to the remaining 3 managers that I want to become the leader of this swarm cluster. So are you agree with this? Are you okay with this? And suppose if majority of the manager remaining from the 3, at least 2 says that okay, we are ready, we don't have any problem, you can become the leader. So this manager 2 will become the leader in that case. So this is again the Raft algorithm which I explained, which I mentioned everything in the details. The same thing is mentioned over here which I have explained you. So you can go through these notes very carefully. This is the very depth of swarm. No one will explain you this one. So I did many things so that I got this one. So you can download these notes from my Facebook group Devops G. There I will be uploading all these notes. So you can download it from there and you can go line by line. You will understand every points. And it is mentioned the same thing, whatever I have explained over here, the same thing is mentioned in these notes as well. So from next session, we will be looking completely practical of the Docker Swarm. So already we have covered 2 sessions for the theoretical parts. What is the Docker Swarm? What is the workflow of the Docker Swarm? So I think now you are aware of at least what the Docker Swarm is. Now when we will move to the practical session, you will get a clear idea, clear picture of what is the Docker Swarm is and how Docker Swarm works. Whatever we discussed in the theoretical session, you can correlate it with in the practical session. So I would suggest that before moving to the practical session, please go through the theoretical session as well, as you can master in the practical only after getting the clear concept of the theory as well. So you can download these notes from my Facebook group. That's all. Okay, bye bye. Next, we see you in your Docker Swarm practical session. Okay, bye bye.